The EvacGo system is designed solely for the use by the fire and rescue service in the event of an emergency. So we have to consider when these type of systems are being used, that the fire brigade are able to take full control. When the fire and rescue service arrive at the product, they'll have their designated fire and rescue key, which will allow them access to the security enclosure. They put in their key, turn the box, springboard in, so it will push the door open. And the fire and rescue service, you can see typically 1.4 meters is the minimum, which is the height we have here. And they should be able to safely evacuate a floor of origin. So they can turn on a floor. And they can deactivate an evacuation alert area. So the toggle switches, they're designed for use with the firefighter's glove. The switches are suitably spaced, and we can evacuate any floor that we see fit for purpose. So turn on the 10th floor again. Upon activation, you can see the LEDs illuminated to say that the floor is actually in alarm condition. It's in an alert. And it's non-latching. We can activate multiple floors, or we can phase the evacuation depending on how the fire and rescue service need control. So the fire and rescue service, they now have complete control of that system. Obviously, if an evacuation alert area goes into a fault, then the appropriate fault LED will illuminate, in which the fire and rescue service will then be tasked to then go and evacuate the residents of the building. Typical standard enclosure, text identification, appropriate location text for the building, and obviously everything should be in parallel. Parallel so we can easily identify the topmost switch is the top floor, and then we're going down the building, 14th floor east, all the way down to the ground floor. Top floor west, all the way down to the ground floor west again. Okay, nice, easy controls, and we have a designated controls for service and maintenance use only. So the service and maintenance companies can then get access to the product using our standard MCA key, same as our fire detection system, in which we can then gain access to the control equipment. We can check the batteries, put the system into test, and test the system for functional operation. So secure, robust enclosure, as you can see, controlled for use by the fire and rescue service. So we identify in some components. So this is our security rated enclosure, the STS-205. You can think of it as a basic safe mounted onto the wall, and it has a designated key which is held by the fire and rescue services. The building owner or the responsible owner should also have one of these keys in place. This key will obviously need to be requested for whenever you service and maintain the system, you want to install, test, program the system. We need to make sure we get access to the key. Once we've got the panel, we're going to identify some typical components. So from your system design, we have a typical loop of devices, isolators outside the flats, and your sounder, your notification device within the internals of the flat. Remember everything to be suitably sealed. The recommended cable, typically enhanced cable, and the infrastructure will then obviously be reporting back to your control equipment, or your EACIE as it's known in industry. So this example is a typical 32 zone system. It could be any combination. If it's 10, 12 stories, then you'll have the relevant switches on the enclosure. Remember, this type of system is for use by the fire and rescue service. So to identify ports, so when you see your enclosure, straight away by the amount of switches you got and the associated text, this will tell you how many evacuation alert areas are utilised in the system. So we have a silence fault buzzer on the system. Silence, we have power fault, and general fault. Obviously, typical system, we only want to see the green power LED. If the system was to have any type of fault, then we'll see a general fault illuminate. If it's in a particular evacuation alert area, the appropriate LED will turn on. Obviously the system has to be connected to an alarm receiving centre, that's what we recommend. But components, the infrastructure of the product, to give you an overview, you have your 4 loops. This is a 4-loop system, but it's only got 2 loop cards fitted. We can easily expand the system simply just by inserting our loop card. Loop card is what's obviously driving the sounders connected to the system. So we then have 2 48-way IOs. The 48-way IO technology is used to drive or to communicate internally with the fire and rescue service toggle switches. Okay, so these banks of 8 cards, so it's all modular in construction. So we have 8 toggle LEDs. Each bank is connected to one 48-way IO card. The second bank is connected to the other. And obviously it's modular in construction, so if the building itself is typically a 10 or 12 story type building, then there will be less populated. You'll have relevant blanking plates and you might have less PCBs in your equipment. But just so you can identify and you can relate to the products. So the 48-way IO cards, we have 16 inputs and 48 LED driver outputs. So the 16 inputs are used for your fire and rescue service toggle switches, and then the appropriate LED indication, your activation, your alarm LED and your fault LED is driven from the same PCB. These components are obviously needed to be configured through our PCNet software package, so we need to install the software, which you can freely download from our website, and then we can use these to configure the equipment. Located behind this PCB will be a network card should we need to network it to obtain more loops on the system. Also on here we can mount up to 17 ampere hour batteries within this enclosure. Any batteries greater than this, then we are looking to supply a separate mounted battery enclosure. The remote battery box would then have to be used, it'll have to be strategically mounted in place in a secure type location. But you've got your batteries here and your battery connection in the bottom. And then what we have is the RS232 serial port. This is for our PC communications, our virtual terminal. And we have our loop connectivity, panel relays for signaling the alarm receiving center and so on. Always remember, once the enclosure is removed, to safely remove the key, and the key needs to go back to the responsible person, the building owner. Okay, that's a key that's held by the fire and rescue service. They have a patented key which will access all enclosures, but this key from your building owner is responsible of that building owner, and it's his responsibility. So make sure you do give that key back to the building owner.